Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations. Today, we're talking about artificial intelligence and its massive, hidden appetite for electricity.
It's a huge issue. We hear about all the amazing things AI can do, but we don't always talk about the fact that data centers full of powerful computers are chugging electricity 24/7 to make it all happen. Global AI demand could reach over 20% of the world's electricity by 2030. That's a staggering amount.
Right, and a new paper from researchers at Ericsson tackles this head-on. It's called A Picture is Worth 1,000 Tokens, How Picture Language Models Cut AI Energy Costs While Improving Accuracy. The title alone gives you a pretty good hint at their clever solution.
I love it. Okay, so before we get to the picture part, let's talk about the tokens part. When we interact with an AI like ChatGPT, everything we type in, words, sentences, even numbers, gets broken down into little pieces called tokens.
Exactly. You can think of tokens as the basic vocabulary of an AI. The more tokens you feed into a model, the more work it has to do to process them, and the more energy it consumes. It scales directly. More tokens, more power.
And this is a particular problem when you're not just asking the AI to write a poem, but asking it to analyze huge streams of numerical data. The paper focuses on telecom network analytics, basically monitoring the health of 4G and 5G cell sites.
And that involves looking at a ton of data points over time. We're talking about performance metrics that are updated every few minutes. When you feed all those raw numbers into a standard large language model, or LLM, they explode into tens of thousands of tokens.
It sounds incredibly inefficient. It's like trying to describe a beautiful mountain landscape by reading out the GPS coordinates of every single rock. You lose the big picture and it takes forever.
That's the perfect analogy, and this is where the researchers' brilliant idea comes in. They asked, what if instead of giving the AI a massive, boring list of numbers, we just showed it a picture?
A picture of the numbers, like a graph?
Precisely. They took the exact same time series data and rendered it as a simple 2D plot, time on the x-axis, the metric's value on the y-axis, just a line on a chart. And then they fed this image to a different kind of AI.
Okay, so not a standard LLM. You need an AI that can see.
You do. They used something called a vision language model, or VLM. These are the models that can understand both text and images. You can show them a picture of a cat playing a piano and ask them to write a song about it. They can see and reason about what they're seeing.
So the experiment is a head-to-head comparison. In one corner, you have a regular LLM reading a giant list of numbers. In the other, you have a VLM looking at a simple graph of those same numbers. Both are trying to do the same task, spot anomalies or problems in the telecom network data.
And the results were just fantastic on two different fronts. First, let's talk about the energy savings. By turning the data into an image, they slashed the number of input tokens by up to 10 times.
Wow, a 10-fold reduction. And since energy use is tied to token count, that must mean a big drop in electricity consumption.
A huge drop. The VLM looking at the image used between 1.8 and 2.5 times less energy than the LLM reading the text. The paper calculates that for a company monitoring just 200 cell sites, this method would save around 7.2 megajoules a day. They say that's equivalent to the daily energy consumption of 2.4 average U.S. households.
That's incredible. You get the same results but for a fraction of the energy cost. But wait, the paper's title says it also improves accuracy. That's the part that feels like magic. How can it be cheaper and better?
This is the coolest part. The VLM that looked at the graph wasn't just as good as the text model, it was significantly better at spotting problems. In one of their key tests, a fine-tuned VLM achieved over 220% higher precision than its text-only counterpart.
So it's more accurate and more efficient. Why? What is it about the picture that helps the AI understand the data better?
The authors suggest that when you feed in raw numbers, the important patterns, like a sudden spike or a slow dip, get fragmented and lost in the noise of thousands of individual tokens. The AI can't see the forest for the trees.
But a graph makes those patterns visually obvious. A spike is a spike. You can see it instantly. The shape of the line tells a story that's hard to piece together from a list of coordinates.
Exactly. The visual representation preserves the structure of the data. The AI can see the overall shape, the morphology of the waveform, and make a much more informed decision.
And there's another very practical benefit they mention. Sometimes the text-based version of the data is so long that it literally won't fit into the AI's memory.
Right. They talk about the context window, which is essentially an AI's short-term memory. For complex scenarios with lots of metrics, the number of tokens from the text data can exceed that limit, making the analysis just impossible. But the image, it compresses all that information down and fits easily.
So in some cases, this visual approach isn't just a nice-to-have for efficiency, it's the only way to get the job done at all.
That's it. And they even pushed it a step further. They experimented with compressing the images, making them lower resolution to see if they could save even more energy.
And did it work, or did the accuracy drop off a cliff?
It worked beautifully. They found they could reduce the image resolution significantly, cutting vision tokens by another 70%, with almost no degradation in accuracy. The coarse patterns the AI needs to spot anomalies were still visible even in the blurrier pictures.
So this seems like such a powerful and widely applicable idea. It's not just for telecom data, right? This could be used for financial, stock market data, medical readings from a hospital, sensor data in a factory.
Anywhere you have numerical time series data, this approach could be a game changer. It's a fundamental shift in how we communicate with AI. Instead of forcing the AI to process data in a machine-friendly but inefficient way, we're presenting it in a human-friendly, visual way that, it turns out, is also more efficient for the machine.
So the big takeaway is that by getting a little creative, we can make AI not only more sustainable and less power-hungry, but also smarter and more effective at its job. It really proves the old saying, or at least the paper's new version of it, a picture is worth 1,000 tokens.
It certainly is. It's a simple concept with profound implications for building a greener, more efficient AI future.